Let's look at the solutions of these questions. If x and y are two positive integers such that x square minus 5xy plus 6y square minus 6 is equal to 0, how many values can y assume? Okay, hopefully you can see these terms here together are all xy, and this is a constant term. So I'm taking it to the right. I will have x square minus 5xy plus 6y square is equal to 6. And now either see it as I'm seeing it as a quadratic in x, wherein the two roots would be in terms of y, and product of them is 6y square. Let the two roots be a and b. AB is 6y square and a plus b is 5y. Sorry, minus 5y. Sorry, 5y only. 5y only. So now I can break this down as x square minus 2xy. Basically, sum is 5, product is 6. Minus 3xy plus 6y square is equal to 6. So I get x common, x minus 2y minus 3y, x minus 2y is equal to 6. So the expression I have is x minus 3y, x minus 2y is equal to 6. This is what we have. So now I have to look at, because x and y are integers, and they are giving me 6, the possible cases are, this is 1, this is 6, this is 6, this is 1, this is 2, this is 3, this is 3, this is 2, and don't forget minus 1, minus 6, minus 6, minus 1, minus 2, minus 3, minus 3, minus 2. We have to check for all these 8 cases. So let's go x minus 3y. So x minus 3y is equal to 1 and x minus 2y is equal to 6. This will directly give me how much? Minus, okay, I'll put it as y is equal to 5 here. When y is equal to 5, how much will x turn out to be? X will turn out to be 16. Is this an acceptable case? Most definitely. This is very much an acceptable case because we needed x and y to be two positive integers. So this works. Hopefully from this, the second iteration will clear this up for you. X minus 3y and x minus 2y is equal to 6 is equal to 1. By this, we will get y is equal to minus 5. At this time itself, I can remove it. I can remove the storyline because y cannot be a negative integer. So this is gone. Hopefully from these cases, you're also identifying. In order to identify the value of y, you have to do this minus this. So if I can use it, this minus this gives me value of y. So here value of y is 5. Here value of y is minus 5. So this is an unacceptable case. Here value of y is 1. Here value of y is minus 1. So this is an unacceptable case. This minus this, I will get minus 5. So this is an unacceptable case. Basically, I can list out possible values of y very, very quickly. Possible value of y here, minus 1, minus 6. So I get 5 here. This is acceptable. Minus 3, minus 2 gives me minus 1. This is unacceptable. And minus 2, minus 3. Minus 2, minus 3. What do I end up getting? 1. Okay. Hopefully you can see. We are only concerned with the possible values of y. We are only concerned with possible values of y, but that does not mean our work ends here. We also have to go ahead and check for each of these values of y, do we get an x that is a positive integer? So we had already gotten a case. Now checking this, x minus 3y is equal to 2 and x minus 2y is equal to 3. So y is equal to 1, x is equal to 5. Yes, this case works. Another case, when y is equal to 5, yes, it is acceptable. When y is equal to 1, let me see. For the second storyline, we would have x minus 3y is equal to minus 6 and x minus 2y is equal to minus 1. So y is equal to 5. If y is equal to 5, x will be equal to how much? Something minus 10 is minus 1. So x will be equal to 9. This case is also acceptable. Final case, x minus 3y is equal to minus 3. X minus 2y is equal to minus 2. Y is equal to 1. If y is equal to 1, x will be equal to 0. This is an unacceptable case. So we've got 3 acceptable cases now. But within these 3 acceptable cases, how many values can y assume? Y can only assume a value of either 5 or 1. And therefore, the correct answer here has to be option D, 2. Next question. A natural number when divided by 40 leaves a remainder of 17. So the number is of the type 40 n plus 17. At this time, hopefully you can see, if I know remainder with 40, I also know remainder with factors of 40. So remainder with 10 is 7, remainder with 5 is 2, remainder with 2 is 1. I know remainder with factors of 40. And I've also been told the same number n when divided by 63 leaves a remainder of 15. So it is 63k plus 15. So this is a number that is divisible by 3, a number which leaves a remainder of 6 upon division by 9. We also know that. What will be the remainder when n is divided by 56? If I need remainder by 56, I need remainder by 8 and I need remainder by 7. Can I get remainder by 8 from anywhere? Yes, from here I can get. Remainder with 8 will be 1. If it is a 40 n plus 17 kind of number, remainder with 8 will definitely be 1. Now I need remainder with 7. From here I will get remainder with 7 is also 1. So remainder with 8 is also 1. Remainder with 7 is also 1. So remainder with 56. Remainder with 56 will also be 1. Remainder with 56 will also be 1. Because basically you have to combine 8n plus 1 and 7k plus 1. Upon combining the LCM being 56n plus 1, this is clearly identified. Answer to the question is 1. Next, a teacher asks a student of his class to find the average of 9 3-digit natural numbers. The student mistakenly takes one of the 9 numbers in reverse order and gets an average which is 22 more than the actual average of those 9 3-digit natural numbers. How many distinct values are possible for the number which was incorrectly read by the student? Okay. How many distinct values are possible for the number which was incorrectly read by the student? Let's see. First thing to notice, there were 8 numbers that were correctly read. So I'm saying for those 8 numbers, E plus the number that is ABC, it was erroneously read as CBA. So the actual average should have been E plus 100A plus 10B plus C, whole thing divided by 9. This should have been the actual average. So now plus 22 is equal to E plus 100C plus 10B plus A, whole thing divided by 9. This is the entire expression. Let's get rid of this 9 at the bottom. So this will turn to 198. This 9 also goes. Now E and E will get cancelled. 10B and 10B will get cancelled. Essentially what we'll be left with is 99 C minus A is equal to 198. 99 C minus A is equal to 198, or C minus A is equal to 2. Therefore, the numbers that are getting created, could be 1 blank 3, 2 blank 4, 3 blank 5, 4 blank 6, 5 blank 7, 6 blank 8, and finally, 7 blank 9. We cannot have the leading digit as 0, and even if I reverse it, it cannot be 0, because he mistakenly took one of the 9-digit numbers in reverse order and gets an average which is 22 more than the actual average of the numbers. 9 3-digit natural numbers. So he could not possibly have taken 8 blank 10. 10 was not available, no? Okay. So these cases are there. And if after this point, 1, 2, 3, 4, 5, 6, 7, if you marked the answer as 7, it would be fallacious, because we are looking for how many distinct values are possible for the number. Let's take just one example, 1 blank 3. Now this blank can be filled up in 10 ways, no? There is no limitation on what value B can take. So you can have 103 misread as 301. You can have 113 misread as 311. You can have 123 misread as 321. So for each of these cases, there are 10 more further sub cases. So total cases that we will have is option D, 70. Next question, what is the largest possible positive integral value of n for which n cube plus 50 is divisible by n plus 5? Okay. The technical way of solving this would be along these lines. N cube plus 50, let me divide it by n plus 5. And then first it will be n square. So I get n cube plus 5n square. I get minus 5n square plus 50. So minus 5n square minus 25n. When it comes down, it will become 25n plus 50. So I need plus 25 now. So this gives me 25n plus 125. Finally, I'm left with minus 75. So this expression, n cube plus 50 by n plus 5 is equal to n square minus 5n plus 25 minus 75 by n plus 5. And what is the largest possible value of n such that this expression remains integral? N has to be 70, and then you can go ahead and mark your answer, option D. This is the technical way of doing it. A slightly smarter way of doing it, which would not require you to know division of expressions, would be along these lines. Why is my pen not working? Okay, would be along these lines. Simply plug in the values and check. Here you've got 45 cube plus 50 divided by 50. Can you see the unit digit for the expression on the top will be 5? And when you're dividing it by 50, the remainder will definitely not be 0. So this is definitely not the answer. Next question, next option. Similarly, 75 cube plus 50 divided by 80. Again, unit digit will be 5. It will not be divisible by 80. So this will definitely not be the answer. Next option, 50 cube plus 50 divided by 55. This one here. So can I take 50 common out? I take 50 common out. I get 50 square plus 1, or 2501 divided by 55. While I can remove the 5 from the numerator and the denominator, neither of these numbers are divisible by 11, and therefore this will also not be the answer. The last option that is left is 70 cube plus 50 divided by 75. As soon as you see this, if I need remainder with 75, I need remainder with 25, and I need remainder with 3. Remainder with 25 is guaranteed. 50 is divisible by 25, and 70 cube, a multiple of 5 raised to a higher power, divisible by 25 is guaranteed. I just need to see if it is divisible by 3. This number here is 3n plus 2. And 70 is 3n plus 1 raised to any power. It will remain 3n plus 1. So altogether, it will necessarily be a multiple of 3. And by a process of elimination, by simple visual aid, you can reach the answer D70. Next question. What is the highest value of n for which 3 raised to the power 64 minus 1 is divisible by 2 raised to the power n? Okay. Hopefully you see this power here is wonderful. So 3 raised to the power 64 minus 1 can be written as 3 raised to the power 32 plus 1 raised to the power 32 into 3 raised to the power 32 minus 1 raised to the power 32. This also I'm writing as 64, which will further devolve into 3 raised to the power 32 plus 1 raised to the power 32 into 3 raised to the power 16 plus 1 raised to the power 16, 3 raised to the power 16 minus 1 raised to the power 16. And hopefully you can see this will keep going down and breaking up. So I'm writing the final expression straight away. 3 raised to the power 32 plus 1 raised to the power 32. 3 raised to the power 16 plus 1 raised to the power 16. 3 raised to the power 8 plus 1 raised to the power 8. 3 raised to the power 4 plus 1 raised to the power 4. 3 raised to the power 2 plus 1 raised to the power 2. 3 raised to the power 1 plus 1 raised to the power 1. And finally, 3 raised to the power 1 minus 1 raised to the power 1. This is the final expression that you will get. Now, for the smaller numbers, it is easier to figure out, easier to fathom what is happening here. Can you see here? This is as good as 2. This is 4. This is 10. And I'm also hopeful up until here, you would possibly be able to see 82. Here you should be, maybe you know, maybe you don't know, you'll get 6562. But figuring out these numbers is going to be very, very painful. We don't know how to figure out these numbers. We don't know how to figure out these numbers. 3 raised to the power 32. We don't know the value of 3 raised to the power 16. Hopefully you don't know the value of. But can you see a patternistic insight that you can potentially see? Apart from this 4, everywhere you're getting a simple multiple of 2. These are not even multiples of 4. Finally, we only need what is the highest value of n for which 2 raised to the power n divides this expression. No? So I've got 1, 2 from here. I've got 2 2s from here. I've got 1 here. I've got 1 here. I've got 1 here. In order to be certain whether this is a multiple of 4 or not, this is a multiple of 8 or not, simply see, can you see remainder with 4 here? 3 raised to the power 16. 3 raised to the power 16 plus 1 divided by 4 if you're looking for. Is this not equivalent to minus 1 raised to the power 16 plus 1 by 4, which is as good as 2 by 4? So the number is a 4n plus 2 kind of number. So the highest power of 2 present within it will also be 1. While we don't know the value, the highest power of 2 present within this number will also be 1. Similarly, for this case, 3 raised to the power 32 plus 1 by 4 is minus 1 raised to the power 32 plus 1 by 4 is as good as 2 by 4. Highest power of 2 present within this expression is also 1. Now, final step is, let's just add these numbers up. So 1, 2, 3, 4, 5, 6, 7, 8. Answer to this question is option B, 8. Hopefully you learned something. That will be all. Okay, bye.